بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. These are some exercises about section 4.1 maximum and minimum values. For each of the numbers a, b, c, d, r, and s, state whether the function whose graph is shown has an absolute maximum or minimum, local maximum or minimum, neither a maximum nor a minimum. So at f of a, we cannot have a local maximum, as we know, because it has to be on an interval. Is it an extreme? Is it an absolute maximum? No, because there are some other values of y above f of a. So f of a is neither absolute maximum nor absolute minimum. What about f of b? Well, f of b is a local minimum because in an interval around b, this is a minimum. But is it an absolute minimum? No, because there is a value less than f of b. What about f of c? Well, f of c is a local maximum, but it is not an absolute because f of s is greater. F of d is nothing, so it's neither. F of r is the absolute minimum. So f of r is absolute minimum. And of course, it is also a local minimum. F of s, so absolute and also local minimum. But f of s is an absolute maximum only. It is not local because it is an end point. Use the graph to state the absolute and local maximum and minimum values of the function. So absolute maximum. Where is the absolute maximum? This point is the highest one. 2, 3, 4. So f of 4 is the absolute maximum. And it's equal to 5. Good. Absolute minimum. Is there an absolute minimum? Well, this is the smallest value of y, but there is an open circle here. So there is no absolute minimum. What about local maximum? Well, this point is an open circle, so it is not a local maximum. F of 4, of course, is a local maximum plus absolute maximum. Now, what about f of 6? F of 6 is indeed a local maximum because in an interval around 6, f of 6 is above, greater than f of 6.1, f of 6.2, f of 5.9, f of 5.8. So in an interval around 6, f of 6 is the highest point. So it is a local maximum. What about local minimum? Well, f of 0 cannot be a local minimum because it's an endpoint. But f of 1, now f of 1 is this closed circle, closed point, this point. F of 1 is 3. Okay, f of 1 is 3. And in an interval around 1, 3 is less than f of 1.1, f of 1.2, f of 0.9, f of 0.8, f of 1 equals to 3 is less than all the values in around 1 or near 1. So it is really a local minimum. F of 2 is also a local minimum for the same reason. And f of 5 is also a local minimum. So we have 3 local minimums or minima. The plural of minimum is minima. So 3 local minima. So this is the answer of question 5. Sketch the graph of a function f that's continuous on 1 and 5 and has the given properties. So the function should be continuous on a closed interval 1 and 5. And it should have an absolute, so 1 and 5, this is 1, and this is 5. So should it has an absolute maximum at 5. So at 5, okay, it's absolute maximum. Absolute minimum at 2. So here it has an absolute minimum. Local maximum at 3. So local maximum here at 3. And local minimum at 4. So local minimum at 4. So if we sketch the graph like this is the function f. It will satisfy all the conditions. Okay, f of 5 is an absolute maximum, f of 2 is an absolute minimum, f of 3 local maximum, f of 4 local minimum. Local minima at 2, of course f of 2 also is a local minimum, plus it's an absolute minimum. Again, function, same function from 1 to 5, but now with other conditions. Absolute minimum at 3. So at 3, it has an absolute minimum here, okay? Absolute maximum at 4. At 4, it has an absolute maximum. Local maximum at 2. At 2, it will go up, but it not as, so it has to stop here, okay? And for example, here. So for this graph, f of 3 is the absolute minimum, f of 4 is the absolute maximum, and at 2 we have a local maximum. Sketch the graph of a function that has a local maximum at 2 and is differentiable at 2. So this is 2. It has a local maximum at 2, okay, and differentiable. So differentiable, any function like this is differentiable. You can even graph a parabola, okay, or cubic function, no problem. At 2, it is differentiable and has a local maximum. Local maximum at 2, continuous but not differentiable at 2. To be not differentiable at 2, there must be a corner here. So we could graph the same function, but at 2 there is a corner. It's the local maximum, but the function is not differentiable, so there is a corner. Function that has a local maximum at 2 and not continuous at 2. Okay, this time not continuous. So if it is like this, and here, for example, like this, so it has a local maximum at 2, and it's not continuous at 2. Of course, this doesn't have to go as a straight line. You could do it like this if you like, okay? Anyway, at 2, it has a local maximum, and it's not continuous at 2 because in an interval near 2, around 2, f of 2 is higher than all the numbers around 2. Sketch the graph of f by hand and use your sketch to find the absolute and local maximum and minimum values. So he needs us to graph, and then we use the graph to find the local maximum and minimum values and absolutes. And use transformation, okay? Use transformation. Well, the first question, this is a straight line. The first function is a straight line, and x is greater than or equal to -1. So the domain starts from -1. If I replace x by -1, -2 times -1 is 2 plus 3, that's 5. So at -1, it is 5. And at 0, because 0 is greater than or equal to -1, it is 3. So this is the graph of the line. Now what do we have? We have f of -1 equals to 5 is absolute maximum. It is not absolute, it is not local maximum because it's an endpoint, and we don't have absolute minimum or local minimum. The graph of 1 over x, when x starts from 1, at 1, if we make a table, if x is 1, y is 1, if x is 2, y is a half. And we know the graph, it's a curve, approaches the x-axis, doesn't touch. We know the graph of 1 over x. The graph of 1 over x is like this, but we are just graphing the part when x is greater than or equal to 1. Again, f of 1 equals 1 is absolute maximum here, and there is no absolute minimum because it doesn't touch 0, and local, no local maximum, no local minimum. Ln x, we know the graph of ln x, but we need the graph from 0 to 2. Well, at 0, len is not defined, and at 2, len would be len 2, and this up to here, okay? This is the graph of ln x up to 2. It passes by the point 1, 0, okay? So what do we have? Again, this point, f of 2 equals len 2 is an absolute maximum. And it has no absolute minimum. It goes to infinity. And this is a vertical asymptote, and no local maximum, and no local minimum, because this is an endpoint. Now, how to graph 1 minus square root of x? Well, using transformations, let us start by graphing this function. This is y equals square root of x. And now the minus sign, y equals negative square root of x. This means transformation about, or reflection about, the x-axis, because we multiplied y by negative. So this would be the graph of y equals negative square root of x. And then taking the graph 1 unit up plus 1 means we take it 1 unit up. And this would be the graph of the square root, or 1 minus square root of x. And this goes to negative infinity. So f of 0 equals 1 is absolute maximum. And it is not local because it's an endpoint, and no local minimum, no local maximum. This is a piecewise function. And there are 3 numbers here, -1, 0, and 1. So we need only to graph between these three numbers. From -1 to 0, it's x squared. So at -1, x squared is 1, and it's closed because there is an equality here. At 0, x squared is 0. And we know that x squared is a curve. The graph is like this. So this is the graph here in this portion. Now from 0 to 1, we have a straight line. At 0, if we put x0, straight line would be at 2, but there is no equality, so I leave this point open while this point is closed. At 1, if I put x1, 2 minus 3 is -1. So now this straight line passes by these 2 points. So what do we have? Well, f of -1 cannot be absolute maximum because there are numbers, values of y greater than f of -1. Do we have an absolute minimum? Yeah, f of 1 equals -1 is an absolute minimum, and it's not local. Now, what about f of 0? F of 0 is 0, okay? F of 0 is 0. So f of 0, which is 0, which is this point now, what does it represent? Around 0, in an interval around 0, f of 0 is local minimum because it is near 0, it is the smallest, the minimum point. Okay, so although it's not continuous at 0, but f of 0 is a local minimum. Find the critical numbers of each function. We remember the critical numbers. To find the critical numbers, we first determine the domain. And the domain of this function are real numbers because it's a polynomial. And now to find the real number, the critical numbers, we find the derivative of the function. And the derivative is 6x plus 1. And now we have to find when the derivative is 0 and when the derivative does not exist. So f prime is always defined, so it cannot be, it always exists. But I can make f prime 0. I can let 6x plus 1 equals to 0. Then x would be -1 over 6. And it is in the domain because the domain is all real numbers. So critical number is -1 over 6 because -1 over 6 makes the derivative 0 and it is in the domain of f. Here, domain of f is also all real numbers. It's a polynomial. Now we find f prime of x, which is 12, x to the power 3 plus 24 x to the power 2 minus 96 times x. This is f prime. And now we search for values that make f prime does not exist, no values. And we search for the values that makes f prime 0. So when we put 12x cubed plus 24x squared minus 96x equals 0, let me check if, yeah, I can divide by 12. So I will have x cubed plus 2x squared minus 8x equals to 0 because I have an equation. And I can take x as a common factor. So I have x squared plus 2x minus 8 equals 0. And now I can factor this into x plus 4 times x minus 2 because 4 minus 2 is 2 and 4 times -2 is -8. So the critical numbers are the numbers that make the derivative 0 and belongs to the domain. Since the domain is R, so the critical numbers are 0, -4, and 2. Because here I will have either x is 0, x -4, or x is 2, and all of them belong to the domain of f. So there are 3 critical numbers for this function. Similarly, first I determine the domain, and the domain here, all real numbers, it's a polynomial. So let me find g prime of t. Well, g prime of t is 5t to the power 4 plus 15 t square plus 50. And now, can g prime be does not exist? Never, because it's always defined. We don't have a denominator. But it could be equal to 0. So let us find the zeros of g prime. So let us put g prime equals to 0. Let me divide by 5. So I will have t to the power 4 plus 3t squared plus 10 equals to 0. Now, there is no way to factor this. If I find the discriminant, which is b squared minus 4ac, it would be 9 minus 4 times 1 times 10, so it's minus 40, and this is less than 0. So it has no real zeros. Okay, so there is no real number that makes g prime 0, and this means no critical numbers for this function. Okay, so this is a nice example in which a function has no critical numbers. Okay, here I have a quotient, and let me find the domain first. Well, if you look to the denominator y squared minus y plus 1, if you find the discriminant again, and let me denote the discriminant by this. So b squared is 1 minus 4 times a times c times 1. So it's -3, again less than 0. So no real zeros, no real zeros for the denominator. And this means that the domain of G will be the set of all real numbers. Now let us find G prime. Using the quotient rule, this is y squared minus y plus 1 to the power 2. Derivative of the numerator is 1 times the denominator minus y minus 1, the numerator, times the derivative of the denominator, which is 2y minus 1. And now we need to simplify g prime of y. So y squared minus y plus 1 minus. Let me multiply these. What would we have here? Y times 2y is 2y squared. Minus 2y minus y is minus 3y. And minus y times minus 1 is a plus 1. Now there is a minus sign outside. So I will have minus 2y squared plus 3y, and minus times plus 1 is minus 1 over all of this square, which means that g prime of y would be y squared minus 2y squared is negative y squared minus y plus 3y plus 2y, and 1 cancels with -1 over all of this, y squared minus y plus 1 to the power 2. So this is g prime of y. Is there any value of y that makes g prime does not exist? No, it would be the 0 of the denominator, but we have checked that this denominator y squared minus y plus 1 has no real zeros. So still the fact that g prime could be 0. And this is a fraction, so it would be 0 if the numerator is 0. And I can multiply by negative sign. So y squared minus 2y is 0. And I can take y as a common factor. So there are two zeros of the numerator. Either y is 0 or y is 2. And both of these values belong to the domain because the domain is R. So the critical numbers of this function are 0 and 2. Here also, let us find the domain first. Well, this time, if I put 2x minus 1 equals to 0, then x is half, which means half makes the denominator 0. So it must be excluded from the domain. So the domain would be all real numbers except half. So half cannot be a critical number because it is not in the domain. Now let us find p prime of x, and I should use the quotient formula. Derivative of the numerator is 2x. Derivative of the denominator is 2. And let us expand. 2x times 2x, 4x squared, minus 2x, minus 2x squared, minus 2 times 2 minus 4 over equals 4x squared minus 2x squared is 2x squared minus 2x minus 4 over 2x minus 1 to the power 2. Now, if I take 2 as a common factor, I'll have x squared minus x minus 2 over 2x minus 1 squared. So finally, p prime of x would be, I can factor the numerator x minus 2 times x plus 1 because minus 2x plus x is negative x over 2x minus 1 to the power 2. Now it is factored and it is in the simplest form, and p prime of x does not exist at x equals half because half makes the denominator 0 and then p prime would be does not exist. P prime equals to 0, okay, if if the numerator is 0, if 2 times x minus 2 times x plus 1 equals to 0, which means x is 2 and x is negative 1. These two numbers belong to the domain of P, while half does not belong to the domain of P because we said that the domain all real numbers except half. So half cannot be a critical number, although it makes the derivative does not exist because it's not in the domain of P. So the critical numbers of P of x are 2 and negative 1. There are two critical numbers. Well, t to the power 3 over 4 and t to the power 1 over 4, t to the power 1 over 4, this is the fourth root of t. And t cannot be a negative number in this case because fourth root of a negative number is not real. So the domain of this function, t should be greater than or equal to 0. So it is from 0 to infinity. That's the domain of this function. If you try to find h of negative 1, the calculator will say math error. Okay, let us find h prime of t. H prime of t is 3 over 4 times t to the power 3 over 4 minus 1. So this is negative 1 over 4 minus 2 times the derivative of t to the power 1 over 4 is 1 over 4 times t to the power 1 over 4 minus 1, so I have negative 3 over 4. Let us write h prime in simplest form. So 3 here in the numerator and 4 in the denominator. T to the power negative 1 over 4, I bring it down to have a positive exponent. And this is negative 2 over 4. It would be 1 over 2. So there is a 1 and 2 here. And I'll bring t to the power negative 3 over 4 down. So it has a positive exponent. So this is h prime of t. Now I need to add these two fractions. So 4, I can multiply this, the second one, by 2. So let me make it 2 here and 4 here. So I have 4 and 4. I can take 1 over 4 uh, outside. Okay, just simplifying the numbers. So 1 over 4, take it outside. So I have 3 over t to the power 1 over 4 minus 1 over t to the power 3 over 4. And let us add these two. So I will have 1 over 4 and then as usual multiply t to the power 1 over 4 times t to the power 3 over 4. You add the powers. 3 over 4 plus 1 over 4 is 1. And then I'll have 3 t to the power 3 over 4 minus t to the power 1 over 4. And now I can take t to the power 1 over 4 as uh, as a common factor because it is the smallest power. You know, I could have done this here from the beginning of the question, but it's okay. So if I take t to the power 1 over 4 as a common factor, okay, so I will have 3. Now, if you divide t to the power 3 over 4 by t to the power 1 over 4, you subtract the powers, okay, and you will have t to the power 3 over 4 minus 1 over 4, that's 2 over 4 or 1 over 2, so t to the power half minus 1, okay, over t. So you can say finally I have uh, t to the power 1 over half, 1 over 4. Well, I can subtract 1 over 4. Yeah, I can simplify more. Okay, I can write it. Finally, 3 t to the power half minus 1 over 4. And this is t to the power 1 over 4. This is t. So I can just subtract 1 minus 1 over 4 is 3 over 4. And this would be the simplest form. Yeah, it was easier to take uh, t to the power negative 3 over 4 from the beginning as a common factor. So why this is the easiest form? Because I can see the zeros of the numerator and the zeros of the denominator easily. So now can h prime b does not exist? And the answer is yes, if t is 0. When t is 0, the denominator would be 0 and h prime will be does not exist. And this belongs to the domain because the domain is from 0 to infinity. Now, can h prime be 0? And the answer is yes, if the numerator is 0. So 3t to the power half equals 1. T to the power half or square root of t equals 1 over 3. So if you raise to the power 2, t would be 1 over 9. And 1 over 9 belongs to the domain of h. So there are two critical numbers of this function, 0 and 1 over 9. So sometimes you need to work hard to find the critical numbers. Well, here, this is 4 over 5. So this is the fifth root. And we have no problem with the fifth root. So the domain of the function here consists of all real numbers. Let us find the derivative. And to find the derivative, I have to use the product rule. So the derivative of x to the power 4 over 5 is 4 over 5 x to the power 4 over 5 minus 1, which is negative 1 over 5. This is the derivative of the first function, plus. Now the derivative of the second function is 2 times x minus 4 times 1. This is f prime. And let me now mm, do better than the previous question by taking immediately the common factors from here. So we have 2 as a common factor. We have x minus 4 as a common factor. And we have x to the power negative 1 over 5 as a common factor. Okay, because negative 1 over 5 is less than 4 over 5. So now 4 over 5 divided by 2, I'll have 2 over 5. X to the power negative 1 over 5 is okay, times x minus 4. Plus 2 is taken, x minus 4 is taken. Now x to the power 4 over 5 over x to the power negative 1 over 5, subtract the powers. 4 over 5 plus 1 over 5, that's 1 over 5, so that's exactly x. So I have 2 times x minus 4. Now x to the power negative 1 over 5, I can just take it below. And here I have 2 over 5x plus x. So this is 7 over 5x and minus 8 over 5. Okay. If you want, you can take 1 over 5 here, okay, outside, and it would be 2 over 5, or you can even write it 5 times x to the power 1 over 5, and here you have 2 times x minus 4 times 7x minus 8. So this is f prime of x in simplest form. And now f prime of x does not exist at 0 because 0 makes the denominator 0. But is it in the domain? Yeah, it is in the domain. So it's a critical number. And if capital prime could be 0, if the numerator is 0, so when x is 4 and when x is 8 over 7. So critical numbers are 0, 4, and 8 over 7. Three critical numbers. I'll stop here, but I'll continue in another video, but I'd like to tell you how to simplify h prime of t here by taking a common factor. This is 3 over 4, this is negative 2 over 4, so I can take 1 over 4 as a common factor. And this is t to the power negative 1 over 4, t to the power negative 3 over 4. The smallest power is t to the power negative 3 over 4, so I can take it also as a common factor. And now 3 over 4 divided by 1 over 4 is just 3. And t to the power negative 1 over 4 divided by t to the power negative 3 over 4. Subtract the powers. Negative 1 over 4 plus 3 over 4. It will be t to the power 2 over 4 or half. And now 2 over 4 divided by 1 over 4 is minus 2. And t to the power negative 3 over 4 is taken. So immediately you have this answer. So above you have 3t to the power half minus 2. And below you have 4. And you have t to the power 3 over 4, which we got here. But even we did a mistake, because this is 3 over 4, we should have a 2 here. Okay, so in fact there is a 2 here. So there is a 2 here. So it is 4 over 9, not 1 over 9. So thank you for this way of simplifying. Please use this way, not this way. This is a longer way. Thank you very much, and I will continue in another video.